In this week's lab, we're going to measure the mass of certain compounds and carry out chemical reactions on them. By keeping track of the changes in mass and tying it into the numbers of moles of the compound present, we can then figure out information about their chemical formulas. In the first part of this lab, we're going to take magnesium ribbon, the same magnesium that we used in last week's lab. So, oops, there's a bunch of it. We're going to take this magnesium ribbon over here, and we're going to heat it up in a crucible. A crucible is a little ceramic cup that allows you to heat something up to relatively high temperatures over a Bunsen burner. Okay, and we can kind of heat it relatively gently, and since it'll be exposed to air, the magnesium will react with the oxygen in the air to make magnesium oxide. Now, you saw this reaction very directly in last week's lab. What we're going to do here is we're going to collect the white ash that gets produced when our magnesium turns to magnesium oxide. We're going to collect that magnesium oxide essentially. By comparing the mass of the magnesium oxide to the magnesium we started with, we can figure out how much oxygen our magnesium oxide picked up. Okay, so let's walk through how to use a crucible and crucible tongs. So obviously our crucible is going to get pretty hot in this experiment, so we need to take certain precautions to avoid either damaging ourselves or the benchtop or our weighing scale and so on. So to do that, we're going to use a set of crucible tongs here. Crucible tongs are, as the name suggests, are used to pick up crucibles. All right, now if you're ever using a pair of crucible tongs, please be sure to pick up a hot crucible by the side, the edge here. Never try to pick up a crucible by both edges because you don't really have a very stable grip, as you can see here. You always want to pick it up by one edge. All right, or the lip, I should say, of the crucible. Okay. So to help us, heat up our crucible over the Bunsen burner, we have a ceramic triangle over here, as you can see. This ceramic triangle has the crucible kind of sit on it like that, and that allows the bottom of the crucible to be heated to a pretty high temperature. All right. Now, while we're heating the crucible, we're going to, at some point, want to prevent that white ash of magnesium oxide flying away. So we're going to partially cover our crucible with a lid. All right. Now, to allow air to get in, we might want to keep that lid open slightly like that, to at least minimize how much magnesium oxide can escape, while at the same time allowing air in to react with the magnesium oxide. Okay. In addition to all this equipment, we also have a heat-resistant pad here. It's really kind of like a ceramic coaster that allows us to set down our hot crucible and avoid it damaging the benchtop, or basically, getting a lot of thermal shock and cracking on the cold benchtop. So we set it down on this heat-resistant coaster to allow it to cool down before we weigh it. Because again, you don't want to put a hot crucible on your mass balance, because that will also damage the mass balance. The first thing we want to do is we want to dry our crucible. The crucible is made up of ceramic, and there are pores in the ceramic that can absorb little tiny droplets of water and water vapor. And we want to avoid that affecting our readings. So we first want to dry off our ceramic by heating it up for about a minute. Okay, so to do that, we're going to start off with our Bunsen burner here. A nice good flame. Again, remember, you can always adjust the gas supply down here at the bottom, or the air supply by twisting the barrel. So we've got a decent blue cone within another cone, so that's usually indicative of a good flame. All right. So we're going to place this underneath here. You want to make sure that your crucible is kind of sitting in the flame over there. and yeah, just let it heat up for about a minute. After about a minute, I can go ahead and turn off the heat. We'll do over there. And now we want to allow our crucible to cool down. This is where that heating pad comes in, or heat resistant pad rather. So I'm going to grab my crucible tongs, take off my crucible lid, and take off my crucible, and let that sit on that heat resistant pad until it cools down. It doesn't have to be perfectly to room temperature, but you don't want it to be so hot that putting it on a cold mass balance will cause it to crack or damage that mass balance. Okay, so if I were to hold my hand over it, I can still feel the heat radiating from my hot crucible. Obviously, don't touch said hot crucible. That's not really good for your skin. But basically, if I can still feel that heat radiating from it, it's probably still too hot. If I can feel it all the way up here. So once it cools down a little bit, we're going to go ahead and get a mass reading on it. We now need to weigh out our empty crucible and cover. Okay, once they've appropriately cooled down, we're going to walk over to our mass balance and, of course, tare it first. So remember, click on the little tare button, and that zeroes the scale. And let's go ahead and open up our mass balance and place our crucible and our cover on our scale. Okay, give it a second to settle down. Okay, that appears to be the mass of our cover and crucible. So now we are set to select our magnesium ribbon and get it ready to begin the experiment. In order for this to begin, we first have to make sure that our magnesium ribbon is kind of clean and free of any oxidation. Magnesium is reactive enough that it might slowly oxidize in the air, and so we want to remove any tarnish that's on our magnesium ribbon. So to do that, we're going to get a little bit of steel wool. Take some of that out. Just grab a little bit of it, and just kind of rub down the exterior. Kind of pinch the magnesium ribbon and slide the steel wool past it. And that should be enough, hopefully, to polish that magnesium ribbon and get the tarnish off of it. Nice and shiny magnesium ribbon now. Alrighty. So, in order for this to work out, we need to figure out how much our magnesium weighs. Alright, because we're going to use that later on to figure out the moles of magnesium that we're starting with, and therefore the moles of magnesium product we should wind up with. So let's go ahead and place this in our crucible so then we can weigh everything together. This will make calculating the mass later on a little bit easier. Okay, so we're going to first of all twist this into a little bit more compact shape, okay, to let that sit into our crucible a little bit easier. Alright, so I'm going to go ahead and drop that in there, and let's go weigh this out. We now want to get the mass of our magnesium, so we need to have it in our crucible, and we'll go ahead and weigh that out together. So first of all, of course, let's tare that mass balance. There we go. Let's put our cover and crucible in there. Okay, make a note of that mass. That's the mass of our magnesium ribbon, crucible, and cover all together. Alright, we're now ready to begin the actual heating of our magnesium. So go got my magnesium ready in my crucible. I'm going to put it in the ceramic triangle and ready to light that up. So let's light up our Bunsen burner. There we go. Let's start heating that up. Okay. So we're going to keep an eye on this. Let's get the camera here so you guys can see this. As soon as this starts to ignite, we're going to have to place the cover on there and get that, basically make sure none of our magnesium oxide escapes. All right, I'm going to get this footage, I think, with my phone because I think the contrast with the webcam's not that great. All right, here you can see the magnesium still being heated. We haven't quite gotten the crucible red hot yet. Just want you guys to be able to see what this looks like. I have my crucible tongs and my crucible cover at the ready, just so that I can be ready to cover up my magnesium as soon as it ignites. Okay. See the crucible bottom starting to get a little bit red hot, so that's a good sign. So hopefully we'll soon get to the point that it's going to ignite. Starting to ignite. And I'll try and cover that up to try and prevent too much of my magnesium oxide escaping. Alright, we're going to just heat that for a few minutes to make sure it all reacts. No more smokes coming from the crucible. We can take the lid off and continue to heat the magnesium for another 5 minutes. So I'm gonna pull that cover off very gently. See that magnesium's pretty much, it's still like mostly converted into magnesium oxide. But we want to just keep on heating it to make sure that it's all converted. But at least it's gotten to the point where that initial ignition isn't kicking off a lot of magnesium oxide. Okay, so we'll just keep on heating that for a couple more minutes. I believe the directions say for 5, and we'll go from there. Alright, looks like it's been about 5 minutes, and that looks like it's pretty well reacted. So I'm going to go ahead and turn off the gas here. And let's set this off to the side to let onto our heat-resistant mat, let it cool down. Okay. So I'm going to pick that up with our crucible tongs. We'll set that down there, let it just sit for a little bit and cool down until we can get to the point where we want to add some water to it. While our magnesium was heating in air, in addition to reacting with oxygen to form magnesium oxide, it's possible that the magnesium got so hot that it reacted with nitrogen in the air, which you remember, nitrogen's really abundant in the air, it makes the majority of air. Some of that may have formed magnesium nitride. All right, now to avoid this, the presence of this magnesium nitride interfering with our results, we're going to add a little bit of water to this to convert it into magnesium oxide and convert the nitrogen to ammonia. All right, so we're just going to add a few drops of water, of distilled water. This is why it's very important to cool down our magnesium product down to like room temperature. If it's still hot, the water might instantly vaporize and kick up dust, basically kick up some of our powder, and we would lose product that way. So we want to avoid that happening, and so that's why I've kind of let that, cool down to essentially to room temperature. All right, so we're just going to add about 15 drops or so. So let's add our 15 drops of water to this.
Let's make it a little bit more, like somewhere between 15 and 20. Just want to make sure I'm getting enough water, you know, kind of getting water to touch all the bits of the magnesium product that we've got there. Okay, now hopefully that'll react with any magnesium nitride that we've produced and convert into magnesium oxide. In the process, we've added excess water, and obviously we don't want that interfering with our results either. So we're going to go ahead and heat this up a little bit longer, just a couple more minutes to drive off that excess water and drive it off as water vapor, and then we should be done with the heating phase of this.
All right, we're going to start off by heating this gently. We want to drive off the water as water vapor, but we don't want to do it so violently that it kicks off product as well. We don't want it to sort of spatter out. So we're going to put this on in our crucible, our ceramic triangle rather. I'm going to cover it up, but again, I'm going to cover it partially. We do need to create a place for water vapor to escape, so we don't want to cover this up fully. Keep that up. Okay, leave a little bit of opening there. Okay. I don't know if it was very obvious when I heated this up before, but there was also an opening like this when I was heating up the magnesium in the first place. I think it was facing away from the camera, so you may not have seen it. But basically, in that case, I had allowed air to get in. Okay, so hopefully that minimized the amount of magnesium nitride we made to begin with. But in any case, let's go ahead and heat this up. Now, because we want to heat this up gently, I'm going to raise up our crucible. Whoops, or the iron ring holding, or the ring clamp rather, holding our crucible in place. Just so that way when I do heat this up, I don't start off by intensely heating it. Okay, so let's light that up. That's probably a good height for both flame and adjusting the heat. It's not like we need to ignite the magnesium again, so that's probably a safe height. Alrighty, it's been about 5 minutes, so I'm going to go ahead and lower this so that I can heat it strongly. I could also raise the flame, but I feel like I don't want to have the flame so high that it's a little bit unmanageable. So I'll lower that a little bit, and we'll raise the intensity a little bit. Alright, that should be able to heat that up strongly and drive off any of our water vapor that may have formed. Okay, so we're just going to heat that up for 5 minutes and then let it cool down and take a measurement.
It's been about 5 minutes of heating this strongly, so we're going to have a peek here and see how it looks. Okay. It looks like it's pretty dry. I think that's definitely strong enough. So I'm going to go ahead and take that lid off. It doesn't look like anything's escaping, but just in case, move that off. And nice and safe and dry on that. And then we're going to go ahead and turn off the heat. Right. And allow our crucible to cool down for a few minutes. All right, let that sit there and cool down to room temperature, or at least close to it, and we'll take our final mass reading of our product. So here's our final mass reading, or final measurement for part A of the lab. So we have our magnesium oxide product in its crucible, as well as the crucible cover. We want to get the mass reading for the whole thing, because we're going to subtract the mass of the crucible and cover that we took earlier. So of course, make sure your mass balance is tiered or zeroed before we begin, which it looks like it is. I don't have to hit the tare button. So let's add our crucible, the product in it, as well, of course, the crucible cover. I guess I could put that on there. Okay, So let's get rid of the glare there. All right, you should be able to make the reading of the mass of your crucible, the cover, and your magnesium oxide product. In this experiment, we're going to decompose sodium bicarbonate, also known as sodium hydrogen carbonate, or more commonly, baking soda. Your lab manual gives you three possible options for how the baking soda decomposes. We see that the solid product left behind could be either sodium hydroxide, sodium oxide, or sodium carbonate. So we're going to use stoichiometry with our results from today's lab to determine which of those actual products is made. As with our magnesium oxide experiment, we need to start off with a clean, dry crucible. Because water can get into the pores of the clay that makes up our crucible, we're going to heat it for a few minutes just to drive off any of that water to start off with. And so, that there. All right, I'm going to turn off the heat that's been heating for a couple minutes. Let that cool down for a bit. Set that over here. Give it a chance to cool down. All right, now that I've given that a chance to cool down, let's get our mass reading. So again, look at our mass balance. We've set that we've tared that to 0. So slide that open, get our crucible in there. And let's add the lid. Okay, there's our initial mass of crucible. Once that settles down, let's give it a second. Okay, there's our initial mass of our crucible. All right, now I'm getting ready to add about 2 grams of baking soda to my crucible. So I've taken the lid off over here, and I just have the crucible itself. So you can see that without the lid, it's somewhere in the ballpark of 29.2 grams. So I'm going to aim for, a little over 31 grams, or somewhere in the ballpark of 31.2 grams, and then I'll reweigh everything. All right. So let's go ahead and aim for that. All right, so you can see I've gotten somewhere around that 31.2 ballpark. Don't make a note of that number because, again, remember, we've left the lid off here. Plus, I want to make sure that this is zeroed when I weigh it on. So I'm going to take this off here. All right, so let's close both doors. Make sure that our scale is zeroed. Second. All right, and there it is. So yeah, now let's weigh both the crucible and the lid together. It's very important that we do that since we had the empty crucible and lid when we started off. So we want to make sure that the lid is present for all of our subsequent measurements. So that way we can, when we subtract that initial mass off the crucible and lid, we're getting the mass of just the baking soda, and then at the end we'll get the mass of just the product. All right, so there's your mass of your crucible, lid, and baking soda, all combined there. And of course, if you subtract our mass of crucible and lid from earlier,
you'll get the mass of just the baking soda.
All right, so now we're ready to heat this up for about 10 minutes or so. So let's pick up our crucible and put it on our clay triangle. All right, let's put the lid on here. Again, we want to keep this lid slightly askew because we're going to be giving off carbon dioxide and water vapor. We want to give it a chance to escape so that it doesn't interfere with our results. So I'm just going to kind of rest this a little bit on the edge here. So we have like a gap for the carbon dioxide and water vapor to come out the top here. Okay. So if you want to see what that looks like from up here, there's a better view for you. Okay, so with that in mind, let's go ahead and get the let's get this Bunsen burner lit. All right, and we'll let that go for about 10 minutes or so. All right, so that's been going for about 10 minutes, so let's turn off the heat. And let's set this down and give it a chance to cool. Okay, so give that a few minutes to cool. When I no longer feel heat radiating from it, we'll go ahead and weigh that out, and then we'll heat it for another minute or two, and then weigh it again and make sure the mass hasn't changed. All right, now that our crucible's had a chance to cool down, we should be able to weigh it. So let's make sure our scale is zeroed. All right, give that a second. All right, there we go. All right, let's add our crucible, and of course we're going to add the lid as well, since we had the lid present when we got the mass of the empty crucible, so we need to make sure we have both of those things. Okay, so give that a chance to settle down, and then we'll make a note of the mass. Again, we're going to heat this up for another minute or so and take the mass again, and hopefully it won't have changed. If it does change, that means that there's still unreacted baking soda in there that we'd want to make sure that we take care of. Okay, so make a note of that mass. Alrighty, let's heat this up one more time just for a minute or so, just to make sure that all of our baking soda has indeed gone. One last time. Hopefully one last time. Okay, it's been about a minute, so let's turn that off. And set this down to cool. Okay, and once that's cooled, we'll take the mass again. We've heated this up for another minute. Let's put it on the scale one more time and make sure that the mass hasn't changed. Because obviously if it has, we're going to have to do this one more time until it stops doing that, or at least one more time, but hopefully it hasn't. I mean, this has been heating up for, we heated this up for about 10 minutes. All right, there we go, and you can see that the mass is still what it was the previous time we weighed it, maybe off by 0.001 or so. But again, I think close enough that we have we should be able to figure out our mass of our product relatively accurately. Okay, so make a note of this mass, and we'll use that as the mass of our product and our crucible and lid.